Hi, my name's Dan, and this video is one in a short series of videos that I'm going to do about some of the principles of logic circuits. It's kind of starting the process of looking towards wider uses of digital logic circuits, and I'm using a piece of software called Digital Works, which allows you to simulate digital electronics for this. I'll put a link down in the description so you can get hold of it if you want it. Um, and in this video, I want to kind of give some background, some basic principles about what's going on in logic circuits, and I'm going to talk a lot about inputs and outputs, really, because digital circuits at their heart are really about one thing, which is to take some information, which is your inputs, and to process that in such a way that you get one or more outputs. Uh, so they're results, and it's a hardware way of doing mathematics effectively. Um, at its heart, things do get much more complicated as you get into more advanced circuitry, and you get things that change and happen over time. But at the moment, we're going to deal with what's called static circuits in this short series, which is basically where you've just got gates, you've got some inputs, and you've got an output. Um, so the basic principle that I want to talk about is this idea that the user of the circuit has some control over what the inputs are going to be, and then the circuit itself controls what the outputs are going to be. And in some kind of reflection of that, we've got these basic gates which do Boolean mathematical uh, processes. So that's an OR gate, that's a NOR gate, that's we're just going along the line here, an XOR gate, an XNOR gate. And we've got a buffer, sometimes called an inverter, which gives us a NOT process. Sorry, not a buffer, a NOT gate. Um, and we've got and NAND. And when you first put them down in Digital Works, they're always facing effectively from left to right, which is that the inputs are on the left and the output, and there's only ever one output from a gate, is on the right. And we can, if you've been looking at the other videos that I've done, you can see that we can wire these things together. So I'm going to wire an output from there. This is a very random circuit. I'm not actually trying to achieve anything particular. I want to show some principles. Um, but there is something that you are not allowed to do, which is to wire two outputs from gates together. Right, I need to talk about that and talk about why. Because it's all part of this process that's going through. Let's just connect that there, so make it actually connect. We're going to add a wire connector there. Connect that one to there. Connect that to there. Where's this going to come from? I'm going to make that come from there. So this is very random. Um, there we go. We've got some inputs that have not been connected to anything. So when we've got wires that are connected together like this, then we can connect more than one input from more than one gate, or in fact from the same gate if we want, to just one output from a gate. But we cannot, as I showed in that example, we cannot connect more than one output together. And if I try to do that, it would give me the same message, unable to connect two outputs. And the reason for this is that uh, a gate doesn't have any control over what's coming in at the inputs. It can't affect its own inputs. It's other bits of the circuit that are affecting the inputs. But it does have control over what the output is. So it is determining the level of this wire. So this wire that's attached to my pen at the moment, will the status of this, whether it's holding a high or a low status or signal, is dependent on this gate here that it's connected to. And if I try and connect it to a wire that's connected to the output from another gate, the question then becomes which of those two gates is determining the state of this set of interconnected wires that are here? And the answer is, if you try to do that in physical electronics, you would potentially cause all sorts of problems. But in order to protect the logic in digital works, it just disallows it. It won't allow you to do that connection of connecting two outputs together. So to reiterate that, you can connect an output from a gate can go to as many inputs as you want, but it can not connect to any more outputs. So it's one output to one or more inputs. Now this, I was just right-clicking that to get rid of that, but that's given me a tag which is usable in macros, and I'll talk about that in a minute. The other two elements that I've been using in these circuits are interactive inputs and LEDs. And these represent things that, well, an LED gives you an indication of a level, so you can connect that to an output from a gate. But let's put another LED in. What happens if I connect an LED to an input? It won't complain, but if I then run that, it can't determine what that LED is because there's nothing telling it whether this is a high or low. So this is why we got the pink here. The LED actually will only become determined if we link it up to something that actually can tell it an input or an output. And if we connect it to that there, then it becomes determined. We can know, and we can interact with that and make it high or low or whatever. So the LED is acting as if it's a gate that only has an input. Similarly, this interactive input is acting as if it's a gate that only has an output. And I hope you can get your head around that. It's a little bit confusing because it's called an input, and it is an input because you can interact with it, and it can take information from the user. But in terms of the circuitry, it's treated as an output. And so you can't put two of those together. Again, for obvious reasons, because the question would be which one of those actually determines the state of that wire that's connected the two together. And I'll demonstrate this. I'm just going to delete that. Let's wire the two together. And it will complain, unable to connect two outputs, which is clearly the same problem that I had before. Yes, I don't want that. Thank you. So, in terms of the circuit, you can think of each gate as having several inputs and one output. The principle is that you cannot connect two outputs together, but you can connect an output from an entity to as many different inputs as you like. The thing that's called an interactive input actually is, in terms of the circuit, has one output. And the LED, which you could think of as being an output, actually just has an input. And the final thing that I haven't talked about is these tags. And if you've watched the video that I've done on how to create macros, you'll see that you use these tags to connect through to a thing called the template editor. And a tag here can either be an input or an output. And when it's been connected to the template editor, that's, even then it's not really determined because in the template editor, let's just open that one that I had previously. Although that says enabled and that says output, that saying output doesn't determine that this pin here is in fact an output. And you've just got to know how to use these and put them together. But Digital Works will, if you've got two things that are acting as outputs, it will not allow you to connect them together, even if you're using macros. I'm saying that with a great deal of conviction, so let's demonstrate it. I'm going to take that clock enable macro that I made in a previous one. So this is the output from it. And if I try to connect that together to the output from a gate here, it should complain at me unable to connect two outputs. But if I connect it to the input, it's fine. Okay. So that's this kind of underlying principle of inputs and outputs to reiterate what I said right at the beginning, digital circuits are all about what outputs do you get for a certain conditions of your inputs. And you might have a large number of inputs, you might only have one input. Um, but the circuitry in between is effectively your Boolean maths processing that determines what your outputs are going to be as a result of your inputs. Keep watching this series of videos because the next video I'm actually going to take this out of the theoretical realm and do a few example circuits so that you can see this in action. But that's it from me for now.